Doing something today called the dot product. Oh boy. Um, Something that happens to have some uses with vectors. So if we have vector u dot vector v, so it looks like times. That's kind of the problem, but all you do, let me define vector u and v. Let's say u is like 2, -3, and v is -4, 6. The dot product, you do the x value times the x value. You don't really multiply. There is no multiplying of vectors, so it's kind of like multiplying, but it's not really. So you do 2 times -4 plus -3 times 6. So it gives you one value. You guys got it, Ty? You do 2 times -4 at plus -3 times 6. So it's just x times x plus y times y. Pretty straightforward. So this would be like -8. Oops, times. I said times, but I wrote plus. So -8 plus -18 is -26. Okay, and how that's going to be used today is we're going to do some angle stuff. If you want to find the angle between vectors, we'll call it theta. You do the dot product of the two vectors that you want to find the angle between, divided by the magnitude of the vectors multiplied. Okay, and then of course, since this equals cosine of theta, you'd have to do cosine inverse of all this stuff. All right, so let's do this as an example. U and V, if I did a little sketch, maybe we can make a guess here. 2, -3 looks, let's see, about like that, because it goes right 2 and down 3. -4, 6, yeah, it's going to be a large angle. Actually, that'd be exactly 180 degrees. No. Yeah, it'd be exactly 180. Let's do it anyway. Okay, -4, 6 looks kind of like that. So, I've already done the dot product. Is -26, that would go on top. And then what does this mean right here with the absolute values? Magnitude. And how do we find magnitude? Right. Yeah, you square the x value, you square the y value, and then you take the square root of it because it makes a little right triangle. So to find the length of this, you do Pythagorean theorem with these two basically. So 2 squared plus 3 squared is 13, so it's square root of 13. And then b 4 squared, -4 squared is the same as 4 squared, right? 16 plus 36 is 52, square root of 52. Simplifies a little bit. It doesn't really matter if I simplify it though, because this is not the final answer. We're going to have to do cosine inverse of all that stuff. To get the final answer. Still works calculator. It's kind of a pain to plug in. Square root of 13 times square root of 52. $180. Magic. Alright. Anyway, it works. So Number 1, here we go. We're supposed to find the dot product of 2, 3, and 4, negative 5. So, you guys remember how I said to do it? 2 times 4 plus 3 times negative 5. This would be 8 plus negative 15. Negative 7. So B, 3 negative 5 dot 7 4. 3 times 7 plus negative 5 times 4. 3 times 7 is 21, negative 5 times 4 is negative 20. So that equals 1. Okay, number 3. Find the value of A if the vectors, oh, I forgot to write this. This was too. Yeah, it doesn't make any sense. Okay. 2, yeah. If the dot product equals 0, the vectors are perpendicular, and if the dot products are multiples of each other, like they're parallel. So, for example, or sorry, not the dot product. If the vectors, if you think about it, it makes sense. Like if we have like 3, 4, and 6, 8, this one's like twice as big as that one. It's basically going to be the same slope. So these two vectors would be the same. You guys got it? So this is going right 3 up 4, this is going right 6 up 8. Since this is basically 2 times this one equals this one, they're going to be the same. Or if it was like 3 times this one equals this one, or 1.5 times this one equals this one, they're going to be parallel. Because these directions kind of tell you the slope. Like the slope of this vector would be like up 4 and over 3. That's the slope of the line. This one would be 8 over 6. But if you reduce 8 over 6, it's the same slope. So these two vectors would be parallel. You can tell if they're perpendicular if their dot product equals 0. Okay, this one doesn't, but I could make it equal 0 if I just did, like, switch these two and make one of them negative. I think that would work. So now 3 times negative 8 is negative 24, plus 4 times 6 is positive 24. So, yeah. Basically, it's because this slope is negative 6/8, which is negative 3/4, and this slope is still 4/3. So they're opposite reciprocals. They kind of cancel each other out in the dot product. Okay, so back to number whatever we're on 3. The value of A, its vectors are to be parallel. So, did I accidentally do number 3 a little bit? No, we're good. Okay. 4, 6, and A, 3. Okay, what would the value of A need to be for these two to be parallel? 2. Right. So this Y value 6 is twice as big as 3, so if we just make 4 twice as big as A, we're good. So if A equals 2, these two vectors would be parallel. Perpendicular. So for perpendicular, we need to set up a little equation. We need the dot product to equal 0. So 4 times a plus 6 times 3 needs to equal 0. So do a little basic algebra here. So that's the perpendicular A. Okay, number 5. Number 5, some of these are just like show your work kind of thing. If u is negative 2, 3, we're supposed to find the dot product of u times itself. So we need negative 2, 3 dot negative 2, 3. Okay, that'd be negative 2 times negative 2 is 4. 3 squared is 9. So 4 plus 9 is 13. Okay, then we're supposed to find the magnitude of u and then square that. So how do we find the magnitude? A squared plus b squared. So basically it's negative 2 squared plus 3 squared. Notice it's kind of like this right here, right? But then we're supposed to square the answer. Well, here's the magnitude, but then we have to square it. So what's going to happen when we do Pythagorean theorem, we have to square root it, but when we square it, because the problem tells us to, that they kind of cancel out. So it's just 2 squared plus 3 squared again, so it's 13. So they just want to point out that it's the same thing. So if you do finding the magnitude is kind of the same as doing the dot product of the vector times itself, but you have to square root it. This is not the magnitude of vector u. This is the magnitude of vector u. Okay, but they didn't ask for that, so. Number 7, same thing, kind of. No, let's just do it backwards. Okay. We're supposed to show that u dot v is the same as v dot u. So I gotta show a little work here. So 5 negative 3 dot 3 7 should be 15 plus negative 21 is negative 6. And then we're supposed to do it in the other order. Show that the order doesn't matter. 7 times 5. Wait, did I write this down wrong? 3 times 5 is 15. 7 times negative 3 is negative 21. So it's negative 6 again. Okay, that's the A. We're showing that they're both the same thing. U dot V is the same as V dot U. For the B, we're supposed to do 2 times U dot V. Okay. I already did U dot V on the other, on the A, so I know it's negative 6. And then we're supposed to show that 2 times U, or dot V, also equal. So 2 times U, U is the 5 negative 3 is 10 negative 6, and the V is 3 7. 10 times 3 is 30, negative 6 times 7 is negative 42, it's negative 12, it's the same thing as the other one. So what does this show? It shows that it doesn't matter if you do the dot product first and then multiply by 2, or if you multiply by 2 and then do the dot product. It's not distributive property though, it's more like order multiplication, doesn't matter. So when I'm grading this, I'll be like looking for the work here in the negative 12s. They should come out the same, okay. Number 9. These are big. Time to take off the jacket. Kind of the same thing, just bigger. Okay, so we got U, V, and W. We're supposed to show kind of that the distributive property works. Like if we do U dot V plus W first, and then dot U, or if we do U dot V plus U dot W, that they're going to be equal. So, lots of work. I'm going to that's the U vector. I'm just going to plug these in. Alright, so we're supposed to show that this is equal to I miss a plus. Yeah, that's the big plus. Kind of a lot. Okay, so on the first one we're supposed to add these first and then do dot. And the second one we do dot, dot, and then add. So, what's 1, 3 plus negative 1, 2? That'd be 0, 5. Then we do the dot product of that with negative 2, 5. Negative 2 times 0 is 0. 5 times 5 is 25. So you get 25. Second one, we're supposed to do the dot product first. Negative 2 times 1 is negative 2, plus 5 times 3 is 15, plus negative 2 times negative 1 is 2, plus 5 times 2 is 10. So the 2 and negative 2 cancel out, you get 25. So they're both 25. So distributive property works is kind of what we're showing you with dot product. Just like multiplication. Number 11, verify that the angle between U and V is 45. So they're kind of telling us the answer at the beginning, but U is 1, 3, V is 2, 1. Alright, you guys remember that formula? It's written on the page before, but you guys remember the formula? Probably not. It's cosine of theta, theta is what we're looking for here, equals U dot V over magnitude of U times magnitude of V. So, you start with the dot product. 1 times 2 is 2, plus 3 times 1 is 3. So, 5 is on top. It's the dot product of U and V. Bottom, what's the magnitude of U? The length of U is 1 squared plus 3 squared, and then the square root of that. 1 plus 9, 9 is 10. So we got square root of 10. Then for V, it's 2 squared plus 1 squared equals 5, so the square root of 5. This does simplify a little bit, but you don't really need to because we're we're not saying that's the answer. We're looking for theta, so if cosine of theta equals all this, we have to do cosine inverse of all this to find theta. So you just plug this in the calculator. You could do that, simplify that a little bit. It'd be easier to plug in the calculator if you just plug in square root of 50 right there. Anyway, that should come out as 45 degrees. They kind of told us the answer on this one. Okay, 13 is the same thing, but they're not telling us the answer this time. We gotta find it ourselves. So we got U is 3 negative 4. And V is 3, 4. Okay, so the dot product is 3 times 3, negative 4 times 4. So 9 plus negative 16. That'll be our top. And then on the bottom, we do magnitude of U. So 3 squared plus 4 squared. You guys remember this one? 3, 4, 5. But, yeah. It's not square root of, it's square root of 25. 3 squared plus 4 squared is 25. Square root of 25 comes out perfectly as 5. And look at B, same thing, 3, 4. So this is the what cosine of theta is equal to. So we have to do cosine inverse of negative 7 25ths. Am I going too fast here? We good? I think it comes out messy. Do they tell us where to round it? Nearest tenth of a degree. You're going to plug it in?
106.3.
Yeah. Okay. Now this one's got a little bit of a trick to it. It gives us A, B, and C. So I'm going to draw the whole picture. It's kind of a tricky one. I'm not going to make my picture accurate because it doesn't really matter, but it'll probably help us figure it out if we have it all. So what's different about this is A, negative 5, 1, that's not a vector. That's a point on a graph. You guys see the difference? They probably should have put vector symbols on these, but so this is, we don't know what the vectors are yet. B is 4, 6. I'm pretty sure I put one of these on the test though, from last year and this year. So we do need to know how to do it. And the question is, find, lost my place. Find a measure of angle A. So we need this one. So angle A is between vectors AB and AC, right? So we need to figure out what AB vector is and what AC vector is, and then we're going to do that stuff. Okay, what is vector AB going to be? So how far is it moving in the x direction? From negative 5 to 4. It's going up 9, positive 9. If you're not sure, you do the x2 minus x1. That'll give you how far it's going in the x direction. The book uses an arrow. I don't like the arrow. I prefer that. Okay, anyway, it's going up 9 in the x direction. And in the y direction, it's going from 1 to 6. So it's increasing by 5. But my picture's not. If I switched my BNC, that would have looked about right. Okay, and then vector AC. How far is AC moving in the x direction? From -5 to 2, 7, and from 1 to 8, 7. So these are the two vectors we need to find the angle between. Do you guys know how we could have figured this out with trigonometry? It would have been harder, but you could do it. You can use law of cosines and do side version of the law of cosines. So you need to find the length of all three of these sides, which would require the distance formula. It'd be a lot of work, so this is a lot easier actually. You have to do 3 distance formulas, that's a lot, and then you have to do law of cosines, that's kind of a lot. It's a bunch of work. Anyways, so we need, remember the formula, I'll rewrite it. The dot product of the two vectors over the magnitude of the two vectors multiplied together. Alright, so dot product 9 times 7 plus 5 times 7. Magnitude, these numbers are kind of big. So we got, let's see, I know what that one is because it's 7, it's like a 45, 90, it's going to be a 7 squared root 2. This one, let's see, it's 81 plus 25 is 106. And again, we don't really need to simplify that. I guess you could leave this as square root of 98. That might be easier to plug in than 7 squared root 2. 7 squared is 49 plus 7 squared is 49, so it's square root of 98. And this is kind of the stuff, but we have to remember you have to do cosine inverse of all that. It's kind of a mess. And let's see, it looks like it comes out as 53.1. You may plug it in. No?
I keep getting an error. I don't know why.
Error. The reason you could get an error is if the numerator is bigger than the denominator. That's not possible. But that's not bigger though. Square root of 98 to the square root of 98 would equal 1. Did you plug it in?
15.9.
What? How dare you?
Yeah,
Let's,
we
okay.
15.9.
Let's go back and make sure I copied everything. 1, 5, oh crud. I was looking at 16. For the A. I copied down the wrong A. Okay, I'm not going to do it again. If I copy down the right numbers, I'm pretty sure I've been right. So, I don't really care which, but 53.1, put 15.9. We'll just put that. So the moral of the story is go slowly. Make sure you're looking at the right problem. I didn't do 16, by the way. I just put the A from 16 down. So 16 is not 53.9.